Okay, so we've got to find fg of x. So this notation is just the same as fg of x. Same thing. That, remember I went through, there's a few different options. And f of g of x, that's the way it gets written sometimes. So basically then, we apply g to x, and then we do the answer to in as x. Okay, so we take g of x, that's the first one, and we do x minus 1. Then that gets used as x in f of x. So that would be x squared, so x minus 1 squared plus 4. Okay, so that is fg of x minus 1 all squared plus 4. Everyone alright with that?
Yeah.
Okay. So the vector 3 minus 1 translates the graph of fg of x to the graph of h of x. So basically, again, it's just saying fg of x, and that is h of x. Same thing. Right, so find the coordinates of the vertex of the graph. Now there's a couple of ways to do this, right, depending on your level of understanding. So, this here is a quadratic, yes? It's a quadratic in what form? Completed square form. Now do you remember, again, that with completed square form, the vertex, which is this point, is to do with those two numbers. That one and that one, yeah? So that was one of the things we definitely talked about. Based on the work that we've done with translations now, hopefully you'll remember that, well, if this is x minus 1, that will have moved x squared 1 to the right, good. And this will be 4 up. So the coordinates of this vertex in this case will be at 1, 4. Alright? Happy with that? Right, so that's how you can use completed square form for the vertex. Now that helps because, well, I know Yana came to me and went, well, how do I apply it to the equation? You actually need to apply it to the equation, because all I need to do now is find the coordinates of the vertex of the new graph. So the vertex just moves 3 right, 1 down. So from 1, 4, the new vertex will end up at 3 to the right, 4, 1 down, 3. There you go. Simple as that. Didn't actually have to do anything with the equation, you just have to apply the transformation. So that's the difference, I think, for those of you that would go straight into going, right, I need to work out the equation, the new equation, and use that to find the vertex, fine, but it's going to take you a lot longer. Okay, so it's that kind of how much do you understand it? All right. Could we try and prove it by actually changing fg of x? Right, so if we've got fg of x is x minus 1 all squared plus 4, how do we apply a translation of 3 minus 1 to that function? So again, we've got 3 right, 1 down. How would we apply, how would we make this function into h of x? What do we do with this to apply that translation? Anyone know?
Would you put the coordinates inside as replacement?
Okay. So in what sense?
So if
Just don't forget 3 minus 1 is not a coordinate, it's an amount of move.
I thought we used
Now I'm redoing this question. So I want to know, guys, I know Yana, for instance, her first thought was, well, I've got to apply the 3 minus 1 transformation to the function. And what she did was multiplied out the brackets and simplified. Okay, and then we changed the function. But this is part of the topic that you need to remember. How do I apply a translation of 3 minus 1 to the function? So do you remember all the things we looked at? If I go back over here, if we start with f of x, we have f of x plus or minus something. We have f of x times something. We have f of x plus or minus something inside. Or we have f of k of x. Or we have minus f of x. You need to remember what each one does, and then we can combine them. So, what does f of x plus or minus k do? Translation. Which direction? Y direction, so up or down. What about k times f of x? A stretch in the y direction. Y direction. The x coordinates don't change.
No, but I mean as in a line. So from the line.
Well, I guess you would say x-axis invariant.
Okay.
But you have to use the word invariant. Otherwise, just saying x-axis doesn't. X-axis invariant. Okay. What about f of x plus or minus k? What does it do?
Translation in x.
Translation in the x-axis, and we have to remember if it's plus 2 with the x, we move 2 left, and if it's minus 2, we move 2 to the right. If we've got f of kx, stretch in the x direction with a factor.
Negative
K.
Oh,
Well, only k, 2.
1 over k.
1 over k. So it's not half k, it's 1 over k. And we've got minus f of x would be reflection y, the x-axis, yeah. And f of minus x, a reflection in the y-axis, so x equals 0. Okay, so we've got all of those, and then we just need to apply those to our function. So if we've got a translation of 3 to the right, 1 down, minus 1, well, let's do the 1 down bit. How do we apply that? Just, it would be f of x minus 1. How do we apply that? If that's f of x, we just do x minus 1 squared plus 4 minus 1.
Ah.
Just write it. Okay, simple as that. Alright, which would become x minus 1 squared plus 3. Yeah? But we're not quite finished yet because we haven't done the, if it's right 3, we've got to do f of x
Minus.
It's going to the right 3,
Minus 3.
so it's minus 3. F of x minus. Now this is the one that I can see lots of blank faces. How do you apply that in here?
Bracket.
Do I understand what to do?
I don't know if that's right, but minus 3 and then open brackets, and you put all of that in it?
No.
No?
Sorry. Okay.
The x minus 3 minus 1, and you do the, it'll be x minus 4 in the end, and you expand that.
What would you say, Valentina?
I would just replace x minus 3 with
Yeah.
So
You both said the same thing. So it become
x minus 3 in brackets, and then minus 1 in brackets, squared plus
okay. So what was x? You replace with x minus 3,
Oh.
and then it becomes, like you said, x minus 4 all squared plus 3. Now using our completed square form knowledge, we look at it and say the vertex coordinates are what and what?
4 and 3.
4 and 3. Remember, it's the opposite. Is that what we found anyway?
Yes.
Mm-hmm.
That is exactly what we found anyway. So either way can work. And actually, the maths is not hard. It's remembering where to put it and write it down. There's no hard maths. I'm not asking you to do, 1.372 to the power of log of 5. All right, in your head. Max, the hardest thing there was having to do -3 -1. I know some of you struggle with that, but I didn't. That was just unfortunate. Do you get the idea? Yeah.
Yeah.
Okay. All right, and then it says, show that it becomes x squared minus 8x plus 19. So how do you show that it does? So again, what did I say? Basically, just ignore that, pretend it doesn't even exist, and
Put 4 and 3. Put replace the other coordinates
so the vector translate the graph to
with 4 and 3. Instead you take the square one and expand it.
well, it depends what I've done, doesn't it? So if I've got to this stage already,
Or you just expand it.
just expand it. If I've done it this way, I would have to replace these with 4 and 3. Okay? So if I do x minus 4 all squared plus 3, who would like to explain how to expand that, just to check? Yannicka, do you want to tell me?
Sure. So first you expand the first bracket.
Yeah,
So
which
it will
is
be x squared minus 2 times x times
Times 4.
okay. So I'm going to just write minus 4x, and then
plus 4
plus 4 squared to plus 16, and then we've got the plus 3, so we end up with x squared minus 8x plus 19, and we go back to the question and just check that it is as I want it, and yes it is. Okay? Alright, so is it starting to get a bit easier now?
Yeah,
Yeah?
makes more sense.
Does make more sense. Now let's just check. Vector translate. Yeah, same thing. Right, forget that one too.
Oh.